Morning. Welcome to the lecture series on digital electronics 18EC302C. In today's lecture, we are going to look at given a truth table, how to write Boolean expression from it. And that is writing Boolean expression from a given truth table. And after getting the Boolean expression from the truth table, then how to draw a logical circuit for the expression obtained. And this will be useful whenever you are given with a truth table. From that you will be able to obtain Boolean expression, and from that expression you will be able to obtain or draw logical circuit. And so how to write, what are the various forms in which a Boolean expression can be written from a given truth table. So normally a Boolean expression can be written from the truth table in two different forms. One is the sum of minterms form, or sum of the product terms. So this is one form, and we also have the second form in which the Boolean expression can be written from the truth table, which is writing the Boolean expression in product of max terms form or product of sum terms form. So, and in each of these forms, the variable may contain in its original form or either in its complemented form. So next we'll discuss in detail how to write Boolean expression from a given truth table, either in sum of products form or sum of minterms form, or as product of max terms form or product of sum terms form. So first we look at the first one, that how to write a Boolean expression from a given truth table in sum of min terms form or sum of product terms form. So assume that we have a function. As an example, we have a function y which depends on the three variables. It depends on three variables a, b, c, and we are given with the truth table of the function. It means for all the combinations of the inputs, for various combinations or all possible combinations of inputs, we are given with what is the value of the function, and this truth table is given to us. And now we will try to write Boolean expression from the given truth table. So first we will try how to write the Boolean expression in sum of minterms form, sum of product terms form. So for that, what we have to do is observe the function, and the function is becoming 0 for certain combinations of inputs, and the function is becoming 1 for the other combinations of inputs. So to express to write the Boolean expression in sum of product terms form, you observe the function, or you observe the input combinations, or you notify the input combinations for which the output function is equal to 1. And here you can see that, so this is the one combination, that is where a equal to 0, b equal to 1 and c equal to 0. The function is equal to 1. So this is one combinations of input for which the function is equal to 1, and you find second term here where the function is also equal to 1, then a equal to 1, b equal to 0, c equal to 0. Similarly, we have two more cases here, right? So in total, for 4 input combinations, the function is becoming 1. The function is equal to 1. So next, what you have to do is, for each combinations of the input for which the function is equal to 1, you write a corresponding product term, or you write corresponding min term. And how to write a min term or product term? So if the value of the variable is equal to 0, then the variable must be taken as a bar. If the value of the variable is equal to 1, say for example b equal to 1, the variable must be taken in its original form. And after taking all those variables in such a way, those variables must be logically multiplied. That is, an AND operation must be performed between the variables taken in that way. So for this combination of input, the product term becomes, since a equal to 0, it is a bar, b equal to 1, so it is b only, c equal to 0, it is c bar. It is a bar dot b dot c bar, simply a bar b c bar. And similarly, another combination for which the function becomes 1 is this, where a equal to 1, b equal to 0, and c equal to 0. And for these values of the input, the product term becomes a b bar c bar. Similarly, for this combination, the product term becomes a b bar c. And for this combination, the product term is a b c bar. Right? So now we obtain the product terms for the input combinations for which the function, Boolean function or logical function, is equal to 1. And while obtaining product terms, we have written the variable in its original form when its value is equal to 1. And we have written the variable in its complemented form when its value is equal to 0. In that way, we obtain product terms. And to write the Boolean expression as sum of product terms or sum of min terms, we have to take the logical sum of these product terms for which the function is equal to 1. So the first product term is a bar b c bar. The second product term is a b bar c bar. The third product term is a b bar c. And fourth product term is a b c bar. So we have to take the logical sum of all these product terms, and this will be the Boolean expression for the function or for the logical function y as sum of product terms. So what we have done simply is to write a Boolean expression from a given table, particularly in sum of product terms form or sum of min terms form. We have identified the input combinations for which the function is equal to 1, and for that input combinations we have written product terms. And while writing product terms, we have written the variable as it is when its value is equal to 1, we have written the variable in its complement form where its value is equal to 0. So in that way we obtain product terms for all the combinations for which the function is equal to 1. And next we have logically added all these product terms for which the function is equal to 1, and that gives the Boolean expression for the function in sum of product terms form. We obtain the Boolean expression from given truth table, and here the Boolean expression is in sum of minterms form. But you can see that this Boolean expression may not be a simplified Boolean expression, and whenever you want to draw a logical circuit for the expression, you can draw a logical circuit for this direct expression obtained from the truth table. But since this is not a simplified Boolean expression, the circuit obtained may not be economical. So to obtain an economical circuit, you can simplify this Boolean expression. So we'll leave that simplifying part to the next topics, but here we'll draw the logic circuit for the Boolean expression which we have obtained directly from the truth table. So next we will look at how to draw a logical circuit for the obtained Boolean expression. So here you see that we have 3 variables. So we'll draw. So this is A, and to get its complement we require complement somewhere. We will put an OR gate, and from this we got A bar, and similarly we will take B, and by using a NOT gate we will obtain B bar, and similarly for C, by using NOT gate we will obtain C bar. Now the first product term is A bar B C bar. So product term A bar B C bar can be obtained by using AND gate. For which one of the input is A bar, second input is B, and third input is C bar. And the output of this AND gate becomes A bar B C bar. And similarly, in order to get the second product, we should have one more AND gate for which one of the input is A, the second input is B bar, second input is B bar, and third input is C bar. The output of this AND gate is A B bar C bar. So this is first product term, this is second gate, and we have one more product A B bar C. We'll take the third AND gate to obtain the third product, which is now the input is B bar, another input is A, and third input is C. So what it gives is A B bar C. And to obtain this product term, we use the fourth AND gate, in which one of the input is C bar and one more input is A and another input is B. So the output of this AND gate is A, B, C bar. Now we have to sum all these product terms. We will use an OR gate. For which we will give these four product terms as inputs. And the output of this OR gate will be the function y. And this is how we can draw a logical circuit for the Boolean function, which is obtained directly from the truth table. So here notice that we haven't simplified the Boolean expression obtained from the truth table. So if we can simplify by using the theorems, then we will get a simplified Boolean expression. And if we draw a logical circuit for that simplified Boolean expression, it will take a less number of gates to draw the circuit. But here we have shown how to draw the circuit without simplifying the Boolean expression. So here we have used only basic logic gates, that is AND gate, NOT gate and OR gate. So this is one way of drawing logical circuit, but keep in mind that this is not the usual way of drawing the logical circuit, because it doesn't give the simplified economical circuit. So next we will see how to obtain or how to write Boolean expression in product of sum terms form. Product of sum terms form. So here this is another way of writing Boolean expression from a given truth table. So here what you will do is, the procedure is, we'll form a sum term. So given a truth table, that means the truth table contains the input variables and the output function, and the truth table shows the value of the function for various combinations of the inputs, and for some combination the output is equal to 0, and for other combination the output is equal to 1. So in order to write the Boolean expression in product of sums form, what we do is we'll form a sum term for each combination of the input in the table, for which the output and for which the function value is 0. And while writing the sum terms, we write the variable in its original form if its value is 0, and we'll write the variable in its complemented form if its value is 1. And to obtain the final expression, we'll take the product of all the sum terms for which the function value of the function is equal to 1. So what we do is, the steps to be followed. The first is, so form a sum term. This we also call sum term as max term for each input combination, for which the value of function is 0. Next, if the variable value is 1, it appears in complemented form. Otherwise it appears in original form. The third one, to get final expression, take logical product of all sum terms. So this is the procedure that is will form some term for each input combination for which the value of function is 0, and while writing some terms will take the variable in its original form if its value is 0, otherwise will take its complement and will write its complemented form. To get final expression, we will take logical product of all sum terms. So this will illustrate with an example that we have written previously. And we'll repeat that once again. So here I assume that we have a function of 3 variables and we are given with the truth table. So this is the truth table given for the function Boolean function y or logical function y. So here we need to obtain the sum terms, and we will write sum terms only for the combinations of input for which the function becomes 0. The function is equal to 0. That means these combinations. And while writing sum terms, we write the variable in its original form when its value is 0. So since a value is 0, a is written in its original form. So it's a sum term, so write plus. And next b variable value is 0, written in original form, and c is 0, so written in original form. So this is a sum term corresponding to the combination a equal to 0, b equal to 0, c equal to 0. And here we have written sum term for this combination because the value of the logical function y equal to 0. But similarly for this case also we write, and this is a plus b plus, here it is c bar because value of c equal to 1. And similarly for this combination it is a plus b bar plus c bar, and for this combination it is a bar plus b bar plus c bar. So this is how we write the sum terms. So finally, to get the final expression, what we have to do is, the final expression is, we have to take logical product of all sum terms for which the function is equal to 1. So that is all these sum terms will take plus c bar, which is a plus b bar plus c bar, and a bar plus b bar plus c bar. We will take logical product of all these sum terms. By this we got the final expression for the Boolean expression for the function from the truth table as product of sum terms. So this is how we can write a Boolean expression from a given truth table, either in sum of products form or product of sum terms form. And here this Boolean expression can also be simplified, or it can be kept as it is to draw a logical circuit. So drawing a logical circuit from this expression is easy when use only the basic logic gates. So here next we will be drawing the logical circuit for the same Boolean expression, and here I am not simplifying this, directly obtaining the logical circuit for this. So here we have 4 sum terms. So it is required to use the 4 OR gates. So since we have 3 variables, so we can also directly write this way. Here the first OR gate has 3 inputs, A, B and C. So here this is one OR gate. Which will give the first sum term. It is A plus B plus C. And to obtain the next, so this is OR gate number 1. So next OR gate we will write somewhat smaller. So this is second OR gate, which if we give the inputs as A and B and C bar as inputs, output of this OR gate becomes AB plus C bar. And similarly, to get the third sum term, we use one more OR gate, for which inputs are A and B bar, and third input is C bar. So the sum term obtained is A plus B bar plus C bar. In a similar way, to obtain the fourth sum term, we will be using one more OR gate, number 4, for which inputs are A bar, B bar, C bar. So by this we get the sum term as R plus B bar plus C. And to get a final expression, we want to take logical product of all these sum terms. So to get a logical product, what we will do is we will take one AND gate, for which the inputs are, first input is this, and input is this, third input is sum term, and fourth input is this sum term, and the output is the product of all these sum terms, which is your function y. So this is how we will be able to draw a logical circuit for the Boolean expression that is obtained directly from a truth table. So for any Boolean expression, we can directly draw logical circuit by using basic logic gates without simplifying the expression. But even we can simplify the expression, and final simplified expression, we can draw the logic circuit. So but if we simplify the expression, we will get logical circuit with a less number of gates, and since when a logic gate takes less number of circuit, it is more economical to construct the circuit. I'm going to the next topic. So first we revise this, but just will review what we have seen in this class. So we have seen a topic that gives a knowledge of how to write a Boolean expression from a given truth table, and for the obtained Boolean expression how to draw a logical circuit. And we have said that the Boolean expression can be written in two different forms. One thing is we can write it in sum of product terms forms or sum of min terms form, or we can write the Boolean expression in product of sum terms form or product of max terms form. And when you want to write those, so first we'll take the case of how to write the Boolean expression in sum of product terms form. So for that we said that the steps to be followed are, so first you are given with a truth table like that. So one example truth table is shown here at the example function. So you will be given a truth table, and the truth table shows the various combinations of inputs, and for each combination the output value of the output function is shown, and its value becomes 0, sometimes it becomes 1 depending on the various combinations of inputs. And to start writing the Boolean expression in sum of product terms form, you identify the input combinations for which the function equal to 1, right? So for some combinations of input the function equal to 1, for remaining combinations it becomes 0. So we'll leave out the combinations for which the function is equal to 0. We'll consider only the combinations of inputs for which the function is equal to 1. So for those combinations of inputs we will start writing product terms. And that means while writing the product terms, the variable will be taken in its original form when its value is equal to 1, and so here b equal to 1, so the variable is taken in its original form, and the variable must be taken in its complemented form when its value is equal to 0. For example, a equal to 0, so it is taken as a bar. So when the variables are taken in that way, we will apply a logical product on those variables to get a product term. So in this way we will obtain product terms for all the input combinations for which the output function is equal to 1. So here in this example function we have 4 combinations of input for which the output function is 1. So we got 4 product terms, and to get the final expression what we will do is we will take logical sum of the product terms that we obtain. So the final expression for the Boolean function as sum of product terms form will be the logical sum of all the product terms for which the function is equal to 1. And in order to draw a logical circuit for this obtained Boolean expression, so we'll use all the basic logic gates, that is AND or NOT gates. So here in detail I have shown NOT gates also, but sometimes you can ignore the NOT gates in order to make the circuit diagram look neat. So you can ignore the NOT gates and you can simply write the variables as this: a bar, b bar, c bar. You can write directly without using NOT gates. So here for every product term, so the expression is in the form of sum of product terms. So each product term can be obtained separately by an AND gate. So first product term is obtained by AND gate 1, second product term is obtained by AND gate 2, and so on. So 4 product terms requires 4 AND gates. 4 product terms require 4 AND gates, and finally to get logical sum of all the product terms we require 1 OR gate. So this way the output of this OR gate will be the final expression for the Boolean function. So this is how we realize or we draw a logical circuit for the Boolean expression, where the Boolean expression obtained from the truth table. In here, in special case, it is in the sum of product terms form, and we have also obtained the Boolean expression in product of sums form. And here we have shown in detail the steps how to obtain the expression in product of sums form. So when you want to obtain the expression in product of sums form, so here we have given example function where all the input combinations are shown, and for each combination we have shown the value of the function, and you have to write the Boolean expression in sum of product of sums form. You identify the input combinations for which the function is equal to 0. So here in the example we have 4 combinations, 1, 2, 3, 4, for which the function is equal to 0. And for each combinations of such inputs, such combination, you write the sum term. And while writing the sum term, the variable is taken in its original form, which value is equal to 0. And the variable must be taken in its complemented form, when its value is equal to 1. So in that way, so here a equal to 0, b equal to 0, c equal to 0. So we obtain the sum term as a plus b plus c. In this way, we will obtain all the sum terms, and in order to obtain the final expression, we will take logical product of all these sum terms. So we will take the logical product of all these sum terms, we will get the final expression for the Boolean function. So then how to draw a circuit for this function, as you can see here. So we have drawn a logical circuit for this. So we have 4 sum terms in this expression, and each sum term can be realized by using a separate OR gate. So if for the first OR gate the inputs are a, b, c, output of OR gate is a plus b plus c. Similar way, we have used 3 more OR gates to realize the 3 more sum terms. And to get the final expression, what you have to do, you have to take a logical product of all these sum terms. So to get the logical product of all these sum terms, what you have to do is we take an AND gate, and for which the inputs will be these 4 sum terms. When you give these 4 sum terms as input for this AND gate, the output of AND gate is the logical product of these 4 sum terms, and that will realize the Boolean function, which is in the form of product of sum terms, which we obtained from the truth table directly. So this lecture illustrates shows clearly how to write a given Boolean expression in 2 different forms. One is sum of product terms form, and another is product of sum terms form, and how to draw the circuit from the obtained Boolean expression. And in next class we will discuss. So here we have drawn the circuit as it is from the obtained Boolean expression without simplifying it. So though we have learned simplifying the Boolean expression by using theorems, so that will not provide a systematic way. So in order to simplify the Boolean expression to get an economical circuit, we require a systematic way of simplification, and that way of simplifying the Boolean expression will be seen and will be discussed in the next lecture. Thank you.